Hey, I am the cat over here. No, I'm Javi Moreno, you already know it. And this time I'm going to talk to you about autoscaling groups in the most straightforward way. This is not going to take a lot of time. You already know that an autoscaling group is basically a service that will allow you to deploy EC2 instances and keep them healthy. If any of those instances have any problem, the autoscaling group is going to detect it, terminate the instance, and replace it with a new one. What do we need to deploy our autoscaling group? The first thing that you are going to need is, of course, a VPC. If you take a look at this, you will see how I have already created a VPC with two different subnets. In this case, I'm just creating two public subnets. You can see them here. This is not probably the best way to deploy an application because you already know that you should try to use private subnets to reduce the exposed surface of your deployment, but this is just a quick demo. So I'm going to deploy the instances on those subnets. What else do we need to do the job? Here you can see several security groups or firewalls that we are going to attach to our resources. The first one is the default. You can ignore it and actually do not ever use the default security group for anything, but you cannot also delete it, so ignore that default group. The fleet security group is going to be our main security group and will provide connectivity to the port 8080 of the EC2 instances for requests coming from, and this is important, this other security group, the Cyberado Load Balancer security group. So we will attach this security group to the load balancer, and only requests coming from the load balancers are going to be able to access the port 8080 of the instance. And of course, the port 8080 of the instance is going to be the port used by our application. Sorry for the glitch. I had a problem with the recording of the screencast. I was telling you that this one is the security group of the load balancer. You got this. We are going to allow access to the port 8080, and from this port you will go to the EC2 instances, to the port 8080 of the instances. Of course, you can access the Elastic Load Balancers from anywhere in the world, and also, because it will make the demo more interesting, we are going to create an administration security group, and the administration security group will allow us to connect to the port 22 of our fleet of servers. This is because I want to show you the CPU of those servers is in real time, and I will do that by executing a top command inside one of the instances. Alright, you will see that later in a moment. Now that we already have talked about the security groups, let me show you the load balancer that I have created. This Liberado load balancer has this endpoint. So if I type this address in my browser, I will access the load balancer. This address with a port 8080 will give us a way to take a look at this tab, the listeners. The port 8080, sorry, I'm going to change this. Because as I said before, I want to access the port 8080 of the load balancer to connect to the port 8080 of the instances. And you can also look at the health check of the load balancer, which is created to ping every 30 seconds to the port 8080 of the instances and ask for the health endpoint. I will show you that health point in a few seconds. Okay, this is the relevant configuration of the load balancer. Remember, the DNS name, this one, the listeners, from port 8080 to the port 8080 of the instances, the health check, and of course, if you look at the description, you will see how we are deploying this load balancer in both public subnets, and in the security part, you can see how we have attached the security group that we have already described. Okay, let me show you the the code of the application that we are going to deploy. We are going to use a calculator for PI. So, we are going to be able to get an approximation of the number P. The code is on GitHub in my personal account, so you can access on github.com/ciberado/pcalculator. Feel free to fork it, modify it the way you want, or even submit pull request, okay? And actually, you can download the binary for this code here in the releases tab. And look, there is a bug on purpose in this code. If you ask for the P with a number of iterations in the approximation of 6667, you will create a bug inside the application and it will consume a lot of CPU. This is what we are going to do to modify to force our autoscaling group to grow up, because we are going to stress a lot the first instance in our autoscaling group. And you will see how after a few minutes the autoscaling group is going to add another instance trying to solve these workload problems, okay? If you want to see live that application, it is not really very sexy, but I have deployed it on an EC2 instance, and you can take a look here. And do you remember the health checkpoint that we have seen before? In this health check endpoint, this path is going to return a 200 code with some additional information that actually is not very important for us, but this is the endpoint that is going to be checked by the load balancer, as we have seen in the previous configuration. All right, and now how do we deploy this application inside an EC2 instance? The first thing that you need to know is the code that you're going to use to customize an AMI with a standard Linux. That code, you can imagine how easy it is actually to write. Is basically this small script that is going to download the release and execute the Java application. This is going to automatically deploy the application, listening the port 8080 inside the instance. You can download this code for copy and paste from the usual address. Actually, if you remember it, you go to pastevent.com, user Javi, and should be easy to find that code from this listing, from this list. In this case, it is the second one, the launch Pi calculator user data. This is the code that we are going to copy and paste in the user data of our EC2 instance. And now, maybe you would think that we would use the EC2 console dashboard to launch a new instance, but actually what we want to do is not to launch a single instance, but to launch an autoscaling group with a group of clone instances. And the definition, the template for those instances is called actually a launch configuration. You can access the launch configuration option here, and don't think about this. I am using the account of the company of Capside, and we have already run a few launch configurations here. We are just going to create a new one. I will press this button and you will see how we provide most of the information needed to create an instance, but we are not going to launch any instance. We are just creating a template. All the instances in the autoscaling group are going to be based on the same template. We are going to select Amazon Linux. We will choose T2 Micro, which is typing good enough for our demo. We will use Pokemon launch configuration for this launch configuration. Pokemon, sorry, it is not Pokemon. It is a P calculator launch configuration. I'm mixing demos. Sorry for that. We are going, and this is very important, to activate the CloudWatch detailed monitoring, because any other way, the granularity of the information provided by the CloudWatch service is going to be 5 minutes, and we really want to react as fast as we can, as quickly as we can. And with the enhanced monitoring, we will be able to get information from the instances each minute. So we will be able to react faster. And in the advanced configuration, do you remember the user data that I have already copied to the clipboard? It's this one. So I paste this small script that is going to be executed each time the Amazon Linux is going to be run inside an instance. I will add storage. Oh, sorry. Let me go back because I want to emphasize that we are going to activate the assign IP address to every instance. That is because we are deploying our instances without a NAT gateway, and we need to connect to the exterior to download the code from GitHub. So GitHub is going, so we need to provide an IP to our instances. Usually this is not necessary because our instance is going to be behind a NAT gateway that will be used to access to this kind of information. And the instance does not need an IP address either to be accessed by our users because they are going to get into our infrastructure through the load balancer. But in this case, let me create a public IP address. And then I will assign a hard disk. 8 gigabytes is enough for sure. We are going to select the security groups that we need, and in this case I'm going to activate the administration security group. This is a mistake in a deployment, in a production deployment, because you do not administrate the instances created by your Autoscaling group. You just take a look at the logs if there is any problem, but I will activate this in this case, and I will also activate this one, which is the fleet security group that will allow us to access to the port 8080 from the load balancer. Okay, I just need to go to the review page, and I already will press the create launch configuration, and I will use this private key. But remember, just because I'm doing a demo, because actually you are not going to in production to access to those machines. Create a launch configuration. And how many instances have we already created? 0. Remember, this is just a template. Let's create an autoscaling group, which is going to be the real service that is going to create instances. I am already here in the autoscaling groups option of the console. It is under autoscaling on the left, autoscaling group, and I will create a new one. Here it is, our P calculator. Launch configuration, our template. I'm going to press next, and this autoscaling group is going to be named P calculator BTS autoscaling group. It is going to be started with one instance, although usually the minimum is going to be 2 because you want to use 2 different availability zones for providing maximum high availability to our design. Remember it, but this is just a demo. I'm going to select our VPC, this one, and I will add both public subnets. Here it is. And in advanced details, we activate, and this is important, the automatic registration of the instances created by the autoscaling group into the load balancer. And the other interesting part is that you should be able to use the health check of the Elastic Load Balancer to know if to terminate the unhealthy instances, but this can bring problems to you if the instance is so busy that it is not able to answer the request from the load balancer. So I will keep the institute check that will only look at the virtual machine from the perspective of the autoscaling group. The application is going to be running if the virtual machine is alive. It is a compromise, okay? And I will give a health check grace period of 300 seconds, 5 minutes, before we try to destroy an instance that has not been correctly initialized. I have another opportunity to activate the CloudWatch detail monitoring. And next, and this is going to be the really sexy part of the demo, next we are going to create 2 different rules to modify the number of instances in our autoscaling group. We are going to scale between 1 and 2 instances. Usually you use at least 2 instances because of the high availability in 2 different availability zones, and a maximum number of instances that you are actually able to pay. In our demo, between 1 and 2 is going to be enough to show you the effect. We are going to create 2 different auto-scaling policies. An auto-scaling policy is a reaction to an alarm that will modify the desired state of an auto-scaling group. If you remember it, the desired parameter of an auto-scaling group will tell you how many instances that auto-scaling group really wants. If the desired is 1 and it has 1 instance, the auto-scaling group is happy. If the desired is 2, because we have executed this auto-scaling group policy, if the desire is 2, but there was only 1 instance, the auto-scaling group is going to create a new one using our launch configuration. The same way, if the auto-scaling group has 2 different instances, but we have executed this auto-scaling group policy that we are going to create here, and the desire becomes 1 after the execution of this policy, the auto-scaling group will automatically terminate one of those instances. I'm going to add a new alarm. I do not want notifications because it is not production. And after the average CPU utilization of the fleet in the autoscaling group, and this is important, the fleet in the autoscaling group is over, let's say, 66%, so our machines are quite busy, for at least one period of 1 minute, because I want this demo to be as aggressive as we can, we will create this alarm, and after and we are going to use this alarm, this threshold, the 66% of CPU for 1 minute, to add 1 instance. You see here how if the CPU is bigger or equal to 66, and obviously it is lower than infinity, then we are going to add 1 instance. And we are not going to do anything else, at least, let's say, for 3 minutes, okay? Because this instance is going to take its time to get into the auto-scaling group and the load balancer, and then trying to take workload from the other instance, trying to help to the other instance to respond to the new connections. The same way, we are going to create a new alarm, but on the other sense, without notifications, and the CPU, if it is below, let's say 20% and in this case, I should place here a big number, because we should always increase aggressively the number of instances, but destroy them in a more conservative way. But this is just a demo, so if for a period of 2 minutes we are under a 20% of usage, we are going to just decrease in 1 instance our auto-scaling group. Again, usually you work with at least 2 different instances on 2 different availability, 2 different availability zones. Okay, this is just a demo. And notifications, I do not want any notifications, but you can add here one to receive information or to automatically perform tasks once the autoscaling group has a new instance, for example. And tags, remember, tags are super important. This is going to be the name is going to be the P calculator BTS security, autoscaling group, and it is going to be also transmitted to the instances created by this autoscaling group. The owner is me, and the project is BTS. Perfect. Let's review this autoscaling group. Looks nice for me. Let's hope I have not committed any error. So we are going to create it. Creating the scaling policies, yes. As you can see, we have successfully created our autoscaling group. Let's take a look at it. Let's go back to the autoscaling group configuration. Come on. Auto scaling group configuration here, And let me show you the details of this recently created auto-scaling group, this one. As you can see, we have a minimum of 1, a maximum of 2, and a desired of 1. This is the default value for the desired. And of course, initially we have 0 instances. So what is going to happen? Exactly, this auto-scaling group is going to create 1. Here in instances, you are going to see how this instance passes from pending to running in a few minutes. But here it is in service. So we can look at the instance. Let me open it in a new tab. All right. And after a few minutes, this instance is going to be in service and automatically connected, registered in the load balancer. Okay. I will press pause right now because I do not want to have you here for 3 minutes without anything interesting happening, and see you in less than nothing. Yoo-hoo! It really took just a few minutes to pass the local health check of the virtual machines, and we can give a second look at the load balancer here, because I want to check again if the instance is correctly registered. Let's load the load balancer. Here it is. Let's go to the instances tab, and the instance is in service. Perfect. So if we access to the endpoint of the load balancer, here it is, and port 8080 slash pi, because this is the path of our application. Okay, we have already been able to calculate pi. Perfect. I'm not really sure how to pronounce pi, or is it pi or p? No, I will ask later to Google. Okay. If you want, we can also load the health endpoint just to look at it. Perfect. Looks like it is working, and we are accessing the instance through the load balancer. Now I'm going to use the IP of the instance directly, because I actually want to, sorry, where is the instance? Is here. Because I want to show you in real time the CPU usage of the instance. This is the IP of our recently launched instance. This is just a console, and I can connect to the instance using the private key that we attach to the instance. Is the username, and this is the IP. And yes, I want to connect to it. Perfect. And I just need to execute the top command to see in real time that we are not actually using too much CPU. Actually, we are using 0 CPU. But if I access the instance through the load balancer or directly, you will see how, by invoking it, I have consumed quite a bit of CPU. Actually, it is very easy because it is a small instance, and the way I have implemented in the calc of P, it is very easy to go to 100% in the CPU usage of the instance. Something that it is especially interesting is to take a look at the metrics provided by CloudWatch. There are several ways to do that, but for example, sorry, I'm trying to find the instance. Here it is. For example, this is our recently created instance. As you can see, it is automatically tagged by the Austoscaling group with the Austoscaling group name. And there is a tab here with the monitoring information. And here you will be able to see the CPU usage with a granularity of 1 minute. After a few seconds, we should be able to see how this is skyrocketing to 100%, because I'm going to invoke that special endpoint. Do you remember it? The number 6667 as a parameter of the by endpoint. This is going to use iteration 6667. And after doing this, you will see on the right how in real time, how the use of the CPU is going really quickly, really high. And it will stay here for some time. Just to ensure that that is happening, I can reload the same endpoint several times, even with the iterations parameter 6667, the parameter iterations. And this is not going to come back to zero for a long time. This is still to 100%. And if we take a look at again at the EC2 instance, sorry, I will close this one. This one, let me zoom it or make it big and reload that option. You will see how we are going over 60%. And that is something that we wanted to happen to show what is the behavior of the autoscaling group. Let's open the autoscaling group console again. It is here. Let's see the monitoring of the autoscaling group. Come on, load! You can do it, console. Thank you. And look, in this monitoring part, after a few seconds, you will see how the number of desired capacity of instances goes from 1 to 2. Yoo-hoo! Here we are! Look at this! We have just passed from one desired instance to two desired instances. But remember, this is because we have surpassed the value of the alarm. That has changed the state of the alarm from OK to alarm, and then an autoscaling group policy has been executed, modifying the parameter of the autoscaling group desired from 1 to 2, but we still had only one instance, so it will take some time to move from one instance to the second one. Oh, we are lucky. It has already launched the new instance, and now we are going to wait a few minutes until this instance is on service. Let's take a look at the instances, at the EC2 instances. This is actually the old instance, which is still trying to answer our request, but we can filter through BTS ASG. Sorry, I will remove this filter. And you can see how we have the previous instance, this one, with the CPU skyrocketing up, but we have a new instance here automatically added by the autoscaling group. So in a few minutes, we should be able to access the new instance and to, with a bit of luck, to get answers from there. If we if we go to the tab with the endpoint of the load balancer, and we just ask for P, for the P value, maybe we are hitting the old instance, but in this case, can you see it? We have actually recovered, we have actually gone to the newly launched instance, and that is actually being able to return as our value. So this has been the demo about how have we added new instances to the autoscaling group automatically, even while you are sleeping at bed at 3 o'clock in the morning on Saturday. And the same would happen the other way if the average CPU of the autoscaling group goes down below 20% because of the other autoscaling group policy, okay? Remember, we need to clean up a bit our deployment. In this case, what we are going to do is to destroy the autoscaling group, which is, you can do that here, actions and delete. This is going to cause the instances to be terminated automatically, both instances. Then we should also remove the launch configuration, even if it is for free. I really like to have account as clean as I can. Here it is. And after this, remember to remove, and this is very important, the load balancer, because each load balancer will make you pay for from $15 to $20 each month. So I'm coming here, and come on, EC2, AWS, and I will remove this load balancer. Thank you very much, sir. Here it is. And of course, if you want, you can also destroy the VPC, but I usually keep them alive because that way I can reuse the same VPC from one demo to the next, and they are for free, okay? So I hope you have found this tutorial interesting, and see you in the next one.